Welcome to this week's IGC Events webinar focused on geothermal, which is presented by Think Geoenergy and Enerchange. My name is Jochen Schneider. I'm the Director of Enerchange. I'm glad to welcome today Ryan Law, the founder and managing director of Geothermal Engineering Ltd, and my co-chair Alexander Richter, the principal of Think Geoenergy, and you everywhere in the world for another Friday's afternoon energy talk. We are really impressed by this week's registrations reaching nearly 500. Therefore, we will limit later in the discussion, which is about half an hour, the number of questions to one per participant, only related to the topic of today's presentation. Let me introduce Ryan briefly. Ryan is a geologist specialized in shallow and deep geothermal systems. He has a degree in geology from Oxford University, a master's in hydrogeology, and a PhD on the transport and modeling of heat in fractured rocks. Ryan is developing with his company Geothermal Engineering Ltd deep geothermal heat and power projects in Europe, including the first geothermal power project in the UK at the United Downs site in Cornwall. He is also the director of Geothermal Energy Ltd, a joint venture between Geothermal Engineering Ltd and Arup to roll out deep geothermal heat projects across the UK and Northern Europe. Ryan, the floor is yours.
Thank you, Jochen, for the introduction. Hopefully people can hear me okay. It's always a bit odd running these kind of things remotely. You have no idea what your audience looks like or how they're responding to any aspect of the talk, or even whether they find your jokes remotely funny or not. So it's always a bit odd, but hopefully we'll have a bit of interaction after the discussion today. So just a bit of background on sort of myself, Geothermal Engineering. We set the company up back in 2009 to look at deep geothermal heat and power projects, and particularly in the UK, which we felt was a long way behind some of the developments that had been happening particularly in Germany, and felt we really needed to start catching up with some of those sort of increasingly common heat and power projects. And so we went down to Cornwall, which is pretty much the hottest place in the UK for a geothermal resource, and developed a combined heat and power project down there to prove a particular concept on the production of high temperature energy, about 180 degrees C from the granite-rich resource in Cornwall. This is a picture of the drilling rig. It's about 56 meters high in what is actually a sort of semi-industrial setting. But one of the reasons for including this picture is really to talk about kind of where we think geothermal is heading. It's obviously becoming increasingly common on people's radar for either electricity or heat supply, and the reason for including this shot is you can see to the in the sort of top right quadrant, you can see one of the old mining engine houses. The area where this particular rig drilled was very heavily mined and was actually the richest square mile on Earth back in the days where Cornwall was producing a lot of tin and copper and other very high value products. And what I think is interesting at the moment for geothermal is yes, it's becoming considered a sort of viable baseload power resource, but increasingly, not just at this site in the UK, but in various parts of the world, starting to look at the possibilities for mineral extraction, high value mineral extraction from some of these deeper geothermal fluids. So yeah, this particular site in Cornwall, we're hoping that not only will this lead to a sort of renaissance of mining activities, but also this combination of sort of bringing mining into the 21st century and trying to make it actually, a sustainable, renewable form of mineral extraction. And for those of you that know the project, you'll probably be aware that there is a very high quantity of lithium within these deep geothermal waters. So it's just this moment where finally, having sort of badgered away at this sort of technology, we can see that there's genuinely a momentum behind geothermal and all of the opportunities that could come from this sort of transitional moment that we're heading into. So just on that, I'm conscious of what the topic is today. This is just one slide on this United Downs project. By all means, get in touch with me afterwards if you want to know more about it. We have a 5.275 kilometer production well, so deepest well in the UK onshore. It's about 187 degrees C, and the key thing about this project is we are really capitalizing on this concept of natural permeability in fractured rocks. It's a very particular geology that we have in the southwest of the UK. There's very particular orientations of stress regime that happen to coincide with some of these very substantial fault structures. So we've been merrily drilling away and testing the performance of both a deep production well and a shallower injection well to prove that fluids can be successfully circulated within these granites. And part of this whole process is in June this year, we'll also run a direct lithium extraction trial from these fluids to really get a sense of the extent to which both lithium and maybe any other high value elements, minerals can be extracted from these resources. So hence the term UK Geothermal Renaissance, but it's not necessarily just the UK. There are many countries, both in the US and in Germany, really looking at cutting edge technology to make these projects this combination of aspects that can help shift the dial, particularly shift the investment dial towards geothermal. So part of this whole sort of business of okay, much more interest in geothermal, great. But geothermal developers, and you can talk to many of them, including myself, have always struggled with raising finance for projects. Projects are often seen as, as rightly so, they're high capital, they're relatively high risk, and they're not like the oil and gas business in that you just cannot afford for any well to fail. Each well must be successful, and the returns obviously do not match a high oil price world. So, from a sort of geothermal developer point of view, we've always been talking to the oil and gas industry, and whether that's about funding for deep geothermal power projects or whether it's about the synergies between the two realms and the extent to which hydrocarbon wells can potentially be repurposed. And the reason there are a number of reasons why we'd be interested in this. So from a development point of view, we're obviously looking at a substantial reduction in capital cost in that the wells have already been drilled. Okay, tick box one from a geothermal development point of view. Drilled wells completed successfully, fantastic. Further to that, most of the wells we've looked at in the world of hydrocarbon, the flow rates are already proven. Yeah, so we know how much water is capable or is already flowing within those wells. So another great box ticked for helping to get funding over the line. And the other aspect for geothermal development is there are a lot of hydrocarbon wells. So great, we've always liked this concept, and there are many people who have looked around the world, mostly on the research side, at how some of these wells could be converted. From an oil and gas point of view, you can understand why, particularly now, and we'll get on to talk about this with these sites we're dealing with in the UK. What is in it for the oil and gas operator? Well, in the past, probably not that much, but at the moment, there are some drivers, particularly not to be cynical, but extending an asset life for another 10, 15, 20 years, so deferring your plug and abandonment costs. And also there is a potential for improving, obviously, a well that has been effectively not used or is no longer producing much gas, or has been left. I mean, to achieve some revenue stream from an existing asset obviously is beneficial. Some other environmental benefits too, which may increasingly drive this sort of shift over. One is renewable heat supply. Those of you familiar with the UK, and it's not just the UK, there are other countries are doing well in terms of meeting their renewable electricity targets, doing far less well on meeting renewable heat targets, because it's just a much more difficult area to deal with, and supply of heat is complex, and existing infrastructure is complex to integrate into. But it can be a potential renewable heat supply, probably far more than a renewable electricity supply. In the UK, that's just unlikely. The temperatures are mostly too low. By the time the geofluid is at the surface, you would have to have so much fluid flowing from these wells. You'd have to have multiple wells in operation to make it anything like worthwhile converting it to electricity. So UK, mostly any conversion of a hydrocarbon well onshore is going to be for heat-only purposes. So some of the challenges to doing this, and we've been sort of at this since 2014 with different operators. It's far more technical. Sorry, it's far more regulatory than technical, and that's partly because it hasn't been done in the UK to set a precedent with the regulators. So we have a combination of three bodies that are effectively involved in this process. So one is the Environment Agency, which governs the abstraction and injection of water underground and waste management. The other is HSE, which really governs safety during operations, particularly with deep wells, and management of barriers for hydrocarbons. And the OGA, the Oil and Gas Authority, which really regulates oil and gas authorities and licenses, and particularly plug and abandonment. So those are the three entities that we always have to talk to try and find a way through to ensure that everybody is happy, particularly with how any sort of license is transferred over to become a geothermal well versus an oil and gas well. And that is actually particularly complex in the UK, because there are no geothermal licenses per se. So the Environment Agency will govern a geothermal project, but it does not, in the same sense that the Oil and Gas Authority does not control sort of long-term, as it were, licensing structure and plug and abandonment policy as the OGA would. So that's always been an interesting hurdle that we've well, hopefully gradually overcoming. On the technical side, it's always going to be dependent on the well, the extent to which the well is producing or not hydrocarbons, the configuration of the well, and the configuration of the wellhead. These are all engineering problems that in general can be overcome, and we'll talk about a couple of specific examples in this presentation. For these onshore wells in the UK, the project team is, as you can see, we've got a combination of ourselves, Geothermal Engineering, with Arup, the consulting engineers, and we have a joint venture company called Geothermal Energy. And we are effectively acting as consultant to the operator, which is Third Energy in the UK. We did start work through Geothermal Energy back in 2014 on a couple of other sites, but eventually those were abandoned. We couldn't do it in time. Times have changed. So the site is in the northeast of England, and this is a site where it was felt that the wells could have produced more gas if it was able to hydraulically enhance those wells. In the UK, hydraulic fracturing is just not really possible right now, under tight regulation, and also there's very, very low public acceptance of what they would term fracking, and been unable to, the developers been unable to develop those wells in the way they would have liked to produce a lot more gas. So these are reasonably modern wells, and we started working with A Third Energy just to review this site and look at which wells might be suitable for geothermal production and why. And we particularly focused in on there are two that are highlighted here. So one at Pickering and a well down at KM8. So at Pickering, what we've been looking at is what we call a conventional doublet system. So we've got two wells that are drilled in to two potentially permeable formations between 1 kilometer and 1.5 kilometers underground. The unit of interest here is not the Sherwood Sandstone. It is actually the Kirkham Abbey. Well, we won't get into the details about why one well actually was perforated to the Sherwood Sandstone, but the actual doublet system will operate within the Kirkham Abbey formation. So all within the same hydrogeological unit, which is pretty key for certainly for Environment Agency acceptance of this type of geothermal system. And the concept is very similar to a geothermal doublet heat system that we might develop in any other setting for heat supply or cooling supply. The only difference in this case is the wells are deeper, and the groundwater level is actually quite a long way below ground. So it's quite different to a sort of standard 150, 200 meter open loop doublet system that we conventionally use. So that's the basic setup for this, and we'll use this. And there's a couple of key things here. That there is a lot of talk about repurposing these hydrocarbon wells, but the reality is, even here where we already have proven flow rates, they're reasonably deep wells. We're really still only looking at temperatures of maybe 51 C within the reservoir. So the time that gets up to the surface, maybe 44, 45, that sort of range, not necessarily hot enough, probably unlikely to be hot enough to supply direct heat. So in this circumstance, we're really looking at about a 650 kilowatt thermal supply. But the key thing is coupled with a ground source heat pump to maintain potentially a hotter temperature, a hotter delivery temperature, to give us more options at the surface in terms of what it can be connected to. In this case, primary use. So luckily enough, there's quite a big holiday home park, and with some plans for a larger expansion and leisure centre, etc. So there's actually a heat load at the site. One of the biggest problems is even if you have a site like this, which looks like it can produce some heat and the setup's pretty good, where is your heat load? How are you going to get a heat load to the site? Very unlikely that any of these wells are anywhere near substantial residential demands. So there has to be some other solution, whether it's a greenhouse, whether it's in this case this holiday park. This sort of thermal delivery, it's 650 kilowatts. It's okay, but you would never really design from scratch a geothermal heat system with those sorts of depths, with that sort of delivery range. The economics wouldn't stack up if the wells weren't already drilled. Well, we're not going to run through the details of this schematic, but we are quite lucky here in that one of the wells already has a electrical submersible pump in it, even though of course that is no longer working, but at least the setup is good enough within the wellhead for relatively minor alterations to make this doublet system work. And the only thing I really wanted to highlight, without getting into too much detail, is that the geofluid is always within its closed loop circuit. So it's never coming into contact with the atmosphere in any way whatsoever. Just runs through a heat exchanger, which is obviously designed to deal with the sort of material that is produced from these deep wells. And we're currently at the running through the detail of the approval process for this system. The other site we're looking at is a much deeper well, actually, but different in the sense that it's about 3 kilometers and it has no perforations whatsoever, so it's not open to any geological units, and is therefore it's hotter because it's deeper, but of course much more limited in the sense that there is no water flow into this well, and therefore we have to design it as effectively a closed loop, what we call a closed loop coaxial system, which in this case really involves circulating fresh water within the well and relying on a process of thermal conduction to bring the heat into the well. But again, you know, we have to link this with a ground source heat pump at the surface to maintain a constant temperature supply. Yeah, because even though downhole temperature is about 85 C, which is nice, pretty good for heat supply, we won't be able to maintain that as we continue to circulate water within the well. It will drop the temperature over time, and therefore we need to link it up with a ground source heat pump to make sure we got a constant supply. And again, look at the thermal supply. You know, 350 kilowatts. It's not huge. It's relatively okay, you know, for a greenhouse or any other agricultural purpose. But just bear in mind, you wouldn't drill a well to 3 kilometers for a 350 kilowatt heat load only. It's just the fact it already exists starts to make the numbers just about stack up. Again, wellhead designs, luckily not too complicated because we're just circulating effectively fresh water within a closed loop circuit. And this is, again, running through the approval process at the moment. It is easier because we don't have any geofluids particularly involved. The whole thing's closed off. And that tends to make certainly the Environment Agency a lot more relaxed about how the regulatory process will work. We are close now to finalizing the economic models for these two projects and running through the whole project financing process with the operator, Third Energy, and we would hope towards third quarter this year to try and receive all regulatory permits for what it is we propose to do and start site development early in 2022. And really, you know, we're doing this partly because it's you know, it's technically fascinating, but primarily we believe we need to start setting some precedents for how this is done in this case in a UK regulatory environment. But really, this process needs to be run through around Europe and around the world to ensure that at least where these wells have been drilled, that we can actually develop them, because there's no point, you know, drilling, you know, let's say there's 11,000 wells to choose from around the world, and maybe, you know, maybe 50% of them won't be any use, but you know, the ones that are of use and the ones that can be driven to supply renewable heat, I mean, it's far better for us to use them than to just shut them down, you know, which has been the normal process until we've reached this point. So I think the real message is look, you know, we're not the only ones working on this, either in the UK or abroad, but let's get these precedents through. Let's do it well. Let's prove that these things can work, and then, you know, continue that discussion with further operators, both in the UK and around the world, to try and make as many of these systems work as we can. Because, you know, once you start to get into the realms of thousands of wells, that still is a big chunky amount of renewable heat that starts to drop the carbon footprint associated with many heating processes. So that's where we are with this. I just wanted this final sort of picture to remind us all of what we've been through. This is one of the workover rigs at United Downs, and shows us perfectly following all social distancing regulations. You know, it's been a difficult year for everyone, I think, to try and do anything in the real world. But I just hope that that the interest in renewables now, you know, I mean, we've seen very strong commitments yesterday, will help to drive this whole process forward, so that at least you know, we can come out of the pandemic with a with a much more hopeful future. So that's where my email address. I'm sure we'll start these discussions now. And the final slide I was asked, that is the final slide as a promotion for the next talk.
Thank you very much for this very interesting presentation with illustrating the vast potential there is in the oil and gas wells we have, and also linking it to the actual climate discussion we see in the world, which is really accelerating. I also welcome here Alexander Richter now as our co-chairman. He will guide you through the discussion as I have to leave. Hello, Alexander, can you hear us?
Yes, I can.
Okay. I will start now with the first question to you, Ryan, and then pass to Alexander. The first question was just at the beginning. Is there a risk that oil and gas companies may not fully take care of their P&A liabilities?
You know, I think a short answer to that would be no, in the sense that even if you're deferring, it's still going to be there. You never ultimately escape the long-term regulation and proper regulation of whether it's oil and gas wells or geothermal wells. So no, I think it's a way of deferring, definitely not escaping.
Hi, Ryan.
There, Alex.
Rather interesting presentation and actually topics. So trying to kind of go through some of the questions here, and there are a lot I see here. One of the questions that came here on the cost of the hydrocarbon well, and let's say I guess the interest of the oil company or that owns the well to make some value out of it. What's your take on that?
Do you mean the actual cost of conversion? Yeah.
Yes.
Nowhere near the cost of drilling a well, and also a lot less than the cost of certainly within the UK onshore, a lot less than the cost of P&A. So ultimately depends what sort of scale of heat is provided, because you know the larger the heat that's provided, the larger potentially the ground source heat pump that's needed. But yeah, I mean we're certainly sub £500,000 for conversion.
I mean, in that context, I think we've heard this internationally a lot. I mean, that there's the cost of tapping a well for an oil company is naturally quite high, and there's a certain cost involved with it.
Yeah.
Could it be a model that there is some kind of element that would require some kind of conversion, you know, so that makes it more like an incentive to do something with the well, and then, for example, like go with geothermal?
Yeah, I mean that's a good question. It's because if you know if the economics are marginal, whether an oil and gas operator would bother to do it, you know, is a question. So whether there is some degree of incentive needed to help that flip over occur is, yeah, it's something that's well worth debating, well worth talking to politicians about.
I mean, and another question here with regards to the utilization for power generation, so with small modular ORC systems. I mean, we've heard about these pilot projects, for example, in Colombia. I mean, is this at all kind of, given the temperatures, a possibility for the UK, or would this be a bit too costly, and then there should be a focus on heat utilization only?
You see, I mean, I just think it's for the UK. For the UK, it's a very, very slim possibility. So if you think about maybe, you know, some hotter wells, you may get to sort of 80 degrees centigrade at the surface, 85 if you're lucky. You know, those sorts of temperatures, your conversion to electricity is going to be 4-ish%. So you're going to need a lot of water flowing through there, yeah, to make that stuck up. So I think realistically in the short term, in the UK, it's much better to focus on heat supply, because unless you've got a massive flow rate, you know, between 100, 150 liters per second, it's just not going to stack up.
Okay, so using a depleted oil reservoir as an example here, and the benefit of drilling cost reduction, with regards to brine decontamination, do you see a challenge there? How would you classify the risk?
it's less of an issue to the extent that these systems are always operating in closed loop. So there's never anything deposited at the surface. There's never anything coming into contact with the atmosphere. The only potential issue is longer term surface pipe work, heat exchangers, the extent to which longer term they're exposed to any degree of norms. So radioactive materials, very low level, but after 25 years, 20 years operation, whether there's some degree of disposal procedure for a heat exchanger or surface pipe work. But that's more the issue.
Re-injection planning and the question about how you deal with the elevated pressure in the injector.
Yeah, that gets us into discussions of every single system will be different. Yeah. Okay. And it's why when people talk about this huge future for geothermal use for hydrocarbons, unfortunately there's no blanket answer. Every single site will be different. The extent to which you need, these are very low flow rates. Yeah, so injection pressures, we're quite lucky in the case of this site onshore in the UK, when hydrostatic alone will inject the water at the sort of flow rates we're dealing with. But higher flow rate scenarios, to what extent you have to potentially enhance the injection well, what sort of treatments you might use to do that, it's a site-specific answer.
Discussions on UK offshore deeper and hotter reservoirs in that context of what you're doing. Are you involved in that, or how do you see that as an option?
Yeah, potentially, but it's all about economics, isn't it? Does it really stack up?
Yeah. Okay. The distance of the two wells at the picking site to the surface.
Oh, the surface. Yeah. That's a good question. At the surface, these wells are on the same well pad, which makes it a lot easier. Yeah. It's not to say it's not inconceivable if the wells are sort of a kilometer apart, provided the operator owns the land, so you don't get into problems of easements for pipe work. But it's much easier if they happen to be on the same well pad and they're just directionally drilled.
Okay. The expected lifetime of these retrofits.
Yeah, the lifetime's interesting, and it really depends on the age of the wells you're dealing with. So for these particular projects, we'd be looking for at least a 15, maybe even 20-year lifespan. But obviously, if you're dealing with wells that are pretty much at the end of their lives, then then the duration is small and it probably just isn't worth bothering with.
Some of the technical questions are probably kind of too cumbersome, so I apologize for maybe not covering those. So the current heat loads that you model, do they cover normal site operating costs, or would kind of the cost of the work over negate any economic benefits?
Yeah, look, the more intervention you have to do, particularly if you have to involve work over rigs, it becomes less and less attractive. You need to find wells where the actual work involved for conversion is relatively low level, and what I mean by low level is more like one would do for a sort of shallow geothermal system. Yeah. But as soon as you start to get into the realms of oil and gas operations, it really does start to become incredibly marginal. If you were talking about perforating casings, some people talk about sidetracking. Just blow your economics off the planet. It just wouldn't happen.
Okay. Some of the questions here related to electricity, and actually in the context of UK, we talked about this, not that much of a potential. The issue of scaling, is that an issue for the sites that you've been working on?
Not on the sites we're dealing with. And this is kind of, it's one of the points I'll make again and again about, and have done before about this. Every single site is different. Every single site has different chemistry, different reservoirs. At this site, that isn't the issue. And we also, there isn't a great big delta T. There isn't a huge temperature differential between abstraction and injection temperature, unlike sort of geothermal power projects. So less of an issue, but it all depends on your reservoir.
Next question here, advantage of simple automation to the system, so ESP monitoring, et cetera, et cetera. Do you see that this could be helpful in making this more mainstream as an option?
Yeah, we always do that in in open loop ground source heat pump systems anyway, you know, extensive monitoring of everything. So it's really just a reiteration of that process.
Okay. Yeah, I think this is a good question as well. I mean, like, is the identification of these prospective oil and gas wells for geothermal, I mean, is it basically just a feasibility mapping, you know, exercise where you look at heat flows and existing wells and data that you can get, and then the way you basically evaluate opportunities, or what would be your take on that?
Yeah, it's just not as simple as that. You need to be speaking to operators. You need to be understanding their site concerns, what some of the sort of logistical issues are, what the heat load possibilities are. It's not just a question of looking at the heat and saying, oh, look, there's I don't know, 20 wells here. It's much more nuanced than that. It has to be a discussion with each operator at each site.
And they need to be open to that. That's, I guess.
Yeah, they do, and they are these days. That's changing, which is good.
Okay, good. Yeah, so here's the question with the management for the high flow rates and the different well sizes. I guess geothermal normally, you know, wider diameters than oil and gas wells. Is that an issue, or is it just basically just a matter of output that you can achieve?
Yeah, I don't think it's an issue. You know, these certainly with these wells we're dealing with, you know, the flow rates are really low. You know, they're nothing like the sort of flow rates we get in a big geothermal power project. They're really pretty low flow rates, which does make actually make the whole process, in this case, cheaper and easier to do. You start to get into much higher flow rates, it does get more difficult really to implement.
Would that be then just like a deep, basically heat pump type of kind of setup in a sense, kind of like a?
Well, I think so, and you know, I don't think there's anything offensive in that. I think it's I think if you're using deep heat to, you know, produce more renewable heat at the surface, fantastic. But yeah, in most cases, you know, I think you do need the heat pump just to give you a constant temperature.
Okay. Public perception, has that differed with these projects compared to kind of like, you know, previously proposed shale gas in the area?
Yes, yeah. I mean, that's a good question. Yes, and I think the public is very, very aware of the difference between hydrocarbons and geothermal. The only caveat to that is people are also wary of people sneaking in shale gas or oil and gas operations under the banner of geothermal. So they'd be suspicious of that in the extent that they think, oh, they're not really drilling for geothermal, they're drilling for oil and gas. But people are far happier with a renewable energy source in general than dealing with a hydrocarbon.
Here, more a comment than a question is like, I mean, naturally, you know, the dependence on what heat flows, what flow rates you have geographically makes a difference. So here's a Hungarian example, like basically where it basically works without a heat pump. And I guess in the case of Colombia, the same thing there. It's just a matter of the situation, I assume.
Yeah, that's absolutely right, and it also depends on the heat use. So if you happen to have a heat user that, you know, let's say it's an open air swimming pool that only needs a supply of sort of 45 degrees centigrade, then absolutely, why bother with a heat pump?
Question here, and I think that's a good one. Is the operator of the geothermal setup taken on the liabilities for the well ownership, like in the case of pollution, etc.? And are there any insurance elements of it? So basically, the notion is like, you know, would you take over from the owner of the well, or would you basically operate this for the owner of the well?
Yeah, no, I mean that is one of the fundamental regulation questions, and it tends to be the case that for now, let's just get these projects through. The operator remains the operator. Yeah, it is very, very difficult to hand those liabilities on at the moment from oil and gas operator. I wouldn't be proposing that at the moment. It'd be just a step too far.
Yeah, I mean, that answers then the question on the ownership model. The project has received any government funding, or is it just purely privately funded?
Yep, this is privately funded at the moment. Always open to government funding, of course.
Yep, the economic value in the cases that you presented, are they mainly about delaying P&A, or?
I think it's a mix of both. It is deferment of P&A for sure. You know, you can set that further down the line. And it's also, you know, if the well has a good 15, 20 years in it, then yeah, there is some return.
Yeah, the depletion of the subsurface heat content. Is this a huge uncertainty, or how manageable is that?
No, in this particular circumstance, it is completely manageable for the doublet system. You know, they're horizontally separated by a good distance, and you know the amount of energy that's actually coming out because of the relatively low flow rates, I'd say it just will make no impact over the duration of this project.
Yeah, so here's a question like with regards to the reservoir layers, do you use the same one that originally used for oil and gas production, or do you isolate, perforate the new formation layer for the circulation?
Yeah, no, that's a good question. In this case, we are sticking to the oil and gas formation. Yeah.
Okay.
And again, it gets back to that question of economics. It's quite likely that the other layer, the sandstone layer, is more productive. But you know, to do that, to make use of that layer, we would have to perforate one of the wells in that location and close off both wells to the original oil and gas formation. Now, just the cost of doing that would mean there's absolutely no point doing this operation.
Yeah, another one which is actually quite interesting. I mean, so in the case of your projects now, you basically looked at abandoned wells, correct?
In the process, yeah, the process of heading towards an inescapable plug and abandonment.
Yeah. So in the context of co-production, do you see like a future of co-producing the hydrocarbons and geothermal heat?
Yeah, that is a good question, and I think yes. Now, you know, we're not dealing with that in this case at the moment on any of these wells, but I think yes, it's another. It's definitely a precedent to be set. Yeah, it's not something we are involved with at this site, but I think there is a future there. But someone needs to take on the whole. How on earth that one is regulated?
The question is with regards to the extracting the heat from these reservoirs and remaining basically a load balance, so you don't deplete the heat. In the context, I mean, is that still research that needs to be done, or how much have you learned in the process of working with that?
Oh, I think over the years you get a sense of what is a sustainable amount of heat for a given separation between wells, and I think at this particular site, I mean, the flow rates would have to be 50 times higher and the energy yield 50 times higher for us to start thinking about potential thermal depletion. The quantities are low in this circumstance.
Perfect. Okay, I think two last questions and trying to combine them in one. Naturally, the rights to the heat or rock and the thermal energy and the oil and gas, do they go together in the UK?
Now that's a really good question. The answer is no, and the UK, because the UK is its sort of own geothermal is in a very grey area. So no, nobody owns the deep geothermal heat. Yeah, it's under law it's classified as a fugitive substance, and there are no licenses for the deep geothermal heat in that form. So in the UK, no. In other countries, there will be interplay between geothermal license owners and oil and gas owners to resolve. Let's put it that way. In the UK, it's not an issue.
Yeah, so I mean, I think that's pretty much it. Maybe just the very, very last question now, and then I'll let you off the hook. And I apologize for the ones that I wasn't able to ask. The question about the well integrity, kind of in a sense, with the conversion. What's your experience in that?
Yeah, so that really gets back again to everything being site specific. Yeah.
Okay.
You know, these wells we're dealing with have a good life ahead of them in terms of integrity. That is not necessarily the case at sites that have been active for a long period of time. So in our case, it's again, you know, we're trying to pick low-hanging fruit to get this going. It will get more complex and more nuanced when wells are older, and then there'll be a big sort of financial question about, is it worth doing for X number of years versus X technical risk, depending on the age of the well.
Excellent. And I think with that, we have to leave it. I mean, naturally, the whole issue of oil and gas, the increasing merging of blurring lines between the different technologies utilizing geoenergy or geothermal energy is utterly exciting. So there will probably be happening so much more. So absolutely exciting to hear kind of your work on that topic and on these projects. Thank you so much for sharing this with us and with our audience. And Ryan, thank you so much for joining us today, and thank you for the participation. That will be the next webinar next week. Will be on the identifying the fracture zones in geothermal reservoirs. This will be a webinar in German, registration over IGC and Invest. With that, Ryan, thank you again. Thank you very much. Good luck with everything else that's going on.
All right. Thanks, Alex. Thank you.
Okay. Thank you. Okay. Bye-bye. And thank you much for joining us.